Hi everyone, we're going to analyze the graph of a rational function. This one's going to have a hole in it, and number 13, 14, and 15 have holes in them. So if you need to see what that looks like, you can watch these videos. This is what we have. I'm going to go ahead and reduce this, or factor this rather. Now, when I look at this, my numerator is p to the x. My denominator is q to the x. So basically, what happens here is I can reduce this function because I can cross this out. And the first thing you always want to do is find the domain. So if you find the domain, you're going to say, well, x is all real numbers, but x cannot be 3, and it cannot be negative 5/2. Because if you set this 1 to 0 and subtract, you get 2x equals negative 5. So x cannot equal negative 5/2. So that's the domain. And normally, if we're going to look at vertical asymptotes, which is step 5, that gives rise to the vertical asymptote. But in this case, we do have a hole. And we have a hole because we have these factors that can cancel out. Okay? So we only have one vertical asymptote, and that's going to be x equals 3. And we'll talk about the hole a little later. Now, our reduced terms, we'll look at that. And let's look at the horizontal. Our degrees are the same. So when our degree in the numerator, which we'll call n, equals the degree in the denominator, which we'll call m, that means our horizontal asymptote is y equals a over b, which basically is 8 over 2. So we have a horizontal asymptote at y equals 8 over 2, which equals 4. Okay, so we will not have a oblique. And then we'll determine if the graph intersects this asymptote shortly. Okay, so basically the first thing we're going to do, we already did the domain, we already did the vertical asymptote. We only have one because we have a hole. And we're going to write this in lowest terms, which we already did, which is 4x plus 3 over x minus 3. So r to the x equals 4x plus 3 over x minus 3. All right, and we're going to use the reduced equation to figure everything else out. Okay, if we search for the x-intercept, we set the numerator to 0. So we have 4x plus 3 equals 0. So 4x equals negative 3, so x equals negative 3/4. So we have a x-intercept at negative 3/4, comma 0. Our y-intercept is when we evaluate r of 0. So that's 4 times 0 plus 3 over 0 minus 3. So that's going to equal 3 over negative 3, which is negative 1. So when y is 0, x is negative 1. Okay, next we're going to determine the hole. So basically what we factored out was this 2x minus 5. And that had common factors in both the numerator and denominator. And we set that to 0 earlier and found that x equals 5 over 2. That generates a hole. So what you do is you plug in the 5/2 into your equation, reduced equation. So 4 times 5/2 plus 3 over x minus 5/2. And that's going to give you 14 over 11. So you do have a hole at 14 over 11. And we will have to graph that. Next, we have a horizontal asymptote. We determined that y equals 4. And so what you're going to do is set 4 equals your reduced equation. So 4x plus 3 over x minus 3. And when you cross multiply, you get 4x minus 12 equals 4x plus 3. These two cancel, so you get negative 12 equals 3, which is not true, so it does not intersect. The graph does not intersect our horizontal asymptote. Intersect, that's a S. EC. Y equals 4. If you had plugged in 4 to your original equation, which happens sometimes, you shouldn't do that. I mean, you don't, it's okay, but when you do that, what you would find is x equals negative 5 over 2. Well, we already know we have a hole at x is 5, negative 5 over 2. It's not defined there, so that would also mean it does not intersect. Okay? You would get different answers, but you would get the same thing where it's undefined. Okay? So it does not intersect either way. Next thing we're going to do is you can put this in the calculator, and I'm going to do a test as if I cannot put it in the calculator, just for those of you all that cannot on the test. And I'm going to pick my hole, which is negative 2.5. Then I'm going to go to negative 2.5 to negative 3/4 because that's my x-intercept. Then I'm going to go to negative 3/4 to 3 because that's my asymptote, my vertical asymptote. And then I need to see what happens to 3 and beyond. So basically, I'm looking at around negative 2.5, which is my hole, which if I didn't have a hole would have been the vertical asymptote, at 3, which is my vertical asymptote, and my x-intercept, where x would be negative 3/4. I want to see the behavior of the graph on this side of the graph and to the right of the graph. Also want to know what's going on in between my x-intercept up to 3 and my x-intercept back on the other side to negative 2.5. Okay, so I got to pick points in between these. You can pick what you want. I'm going to go ahead and choose, where am I? I'm going to choose negative 3. So you choose a number. I'm going to choose negative 3, negative 1. Of course, I'm going to choose 0, and I'll choose 6 here. And then I had to find the value of r. Actually, find your y. So r of negative 3, r of negative 1. Put these in your reduced equation, or you're going to make life harder for yourself. R of 6. When we plug that in, we're going to get 3/2. Negative 1 is going to get mapped to 1/4. 0 maps to negative 1, which we already knew that. And 6 maps to 9. And let's look at the location of the graph. So basically, since y is positive, this is above the x-axis. Positive. This is above. And this one's going to be below here. And this one is above. Actually, you think we forgot to test for symmetry. There is no symmetry on this, so we didn't do that, but that's okay. Let's graph this. I'm going to graph my asymptote at x equals 3. I'm going to go ahead. I've got too many big numbers. I'm going to go by 2's. So this is going to be like 2, 4, like this. So x equals 3 would be right here, kind of in the middle there. X equals 3. This would be 2, 4. And I have a horizontal at y equals 4. I did a point over here at negative 3/4. And, well, we have negative 3/4 and 0, which is right here. That's your x-intercept. Your y-intercept is 0, 1. Your whole is at negative 5/2, which is 2.5 and 1. So we're at negative, this would be 2, so it's about here and a little bigger than 1. So there's your whole. That's going to be negative 5/2 and 14/11, which is a little bigger than 1. Okay, and it never can cross the, looks like I'm crossing here. I'm not. Let me erase this. It doesn't cross the horizontal, so it goes like this. This is just the point of the hole right here, and I'll put the hole in purple. There's your hole. And then I also had the 0.69. So this would be 6 and 9 would be here. Have a point there. And then you just kind of draw it within the asymptote, the vertical and the horizontal. And there is your graph. Okay, the next two videos are going to be similar. They're going to be the ones with the holes. Thank you and have a nice day. Bye-bye.